Bismillahirrahmanirrahim. I'm going now to solve the example 6.1 on page 161, where it says that calculate the molarity of a solution containing 7.5 moles of calcium carbonate in enough water to make 1.50 dm cube of solution. So it's so simple. What is demanded? Calculate the molarity. So see M, I have simply written M. Now what is the moles of calcium carbonate, CaCO3? That is 7.50, and volume. This is what you need to know, the skill, that how you can take out the data. Now over here we have now the solution is easy for us when we collect this data. So the solution is, over here we are writing the formula. The formula is, as we have discussed just before, that the moles of solute dissolved per volume of solution and dm cube. So putting the values 7.50 divided by 1.5, the answer is 5 moles per dm cube. You can write it as well, like this, also like this, 5 moles per dm cube, or 5 moles per dm cube. When you are taking it from the denominator to numerator, you already know that you can write it like this. Similarly, and another question or example, which is 6.3, which is 6.3. It's on page 6.2, sorry, it's on page 163. What we need to do is, first I think you should focus on the question. 5.85 grams of NaCl is dissolved in water so as to make the solution, to make 500 cm3 solutions. Determine the molarity. Atomic mass is given of sodium and chlorine. Okay, as we are given now the grams, which we have already done such like questions we have done in the mole chapter, in chapter 1. How can we convert grams into moles? So it is so easy. This is how I have taken the data from the question. The amount of NaCl is 5.8, given in the start of the question. Clear? Given in the start of the question. The molar mass of NaCl can be calculated from these two values by adding 23 and 35.5, which is 58.8. So moles of NaCl you already know from chapter 1. How can you calculate the mass in gram of solute divided by the molecular mass, or anything, solute or anything, you want to change the grams of which into moles. So when we divide this, so calculate it, it will come out to be 0.1. Volume of a solution, we are given the volume in the question in cm3. So in formula we are given dm3. So we have to change cm3 into dm3 by dividing it into 1000. So it comes up to be 0.5. You can check it with your calculator. Now putting these values over here in the formula, in the solution, molarity is equal to moles of solute divided by volume in dm cube. So 0.1 is the number of moles of solute in NaCl, divided by 0.5 the number of the volume of solution in dm cube 0.5. The answer is 0.2 moles, or you can write it 0.2 moles per dm cube. Clear?